So now you have the y bar equation, right? So k, you put the value, epsilon, you put the value, n is 0.2, n plus 1 is 1.2, you solve it, right? And you get the values. And then y bar dash is 2 upon root 3 or 1.15 multiply by that, so you find the y bar dash. Once you have it, then you put it in the force equation, force LW and so on. So you put that. Here again they are using kilogram, forget it. Don't use there, I mean just put all the values, in metric units and your answer is in Newton. So it will be in kilonewton, meganewton and so on. And finally, you put all of those into the power equation. The only thing different, if you notice, is it is 2, because that was power per roll. Right? So power for 2 rolls, because 2 rolls are required. So power per roll you have multiplied by 2 and you get the total power. And right, so it is 544.267 kilowatt or 554.267 watt and so on. So this is your answer of the whole equation, of the whole problem. We now go to a new topic on roll bending, but let me just reiterate, rephrase, re-stress what I have been saying whenever I start a big long problem in this chapter. We did that in forging, now we have done that in rolling. We have selected for you from the book and so on, even one example. I mean, though we are doing a second one where some theory is being solved, but this example where you do actual calculations for the manufacturing process of rolling. One example, the one that we did, if you understand all the concepts about the roll contact length, about calculating the flow stress or the average flow stress or the flow stress in the plane strain, about finding the roll force with small friction, with large friction, about finding the power in one roll, in two. If you understand all of that and you do even this one question without anybody's help, you just look at the question, you open your pages and so on and you solve it and you go step by step. Of course, you have the full properties table and the full formula sheet with you. So even if you do this one problem very thoroughly with total understanding, with your brain light on, then you don't need a lot of extra practice, right? Of course, you will do more. I will give you some homework practice and so on. You will do more. But please, the examples that we do during the class, really do them very much independently. Don't look at the solution until you are 100% right that we have found all your difficulties and problems and so on. And then repeat them without looking at my solution and so forth. Okay, now back to roll bending. Roll bending. It is a very big exaggerated diagram, but suppose this is the billet material. This is the billet material. And this is the roll. One roller above, one roller below, and they are rolling in opposite directions, of course, to squeeze the material through them. Now, if the roll diameter is too big, the weight is big, and especially if this length along the horizontal axis is big, now this will act as a beam. And you know that on beams and so on, there is bending, right? There is a torque, there is a bending. So if the length of this roller is big and the weight is large enough, then some bending can happen. And if any bending is there, then of course the rolling that you are doing will not get a uniform size. It will not be an exact rectangular size that is coming out of it, but the ends will be slightly shorter and the middle will be slightly, it will be a little like barreling in forging, right? Here it is a very exaggerated view, of course. It will bend very, very small amount. So what we are saying here is then bending of a straight cylindrical rolls in an exaggerated format because of the roll force. But here if you see, what do you see? What is the difference between this diagram and this diagram? Here it is red, here it is green. Yes, but what is the major difference? Here the roll has the arc and here the roll has been flattened. You see, the roll has been flattened on the inside, So if that is done, if we find that some very small amount of roll bending is happening and we do that flattening, then that curvature that is going to be there because of roll bending is now gone, right? So here in B, bending of rolls ground with a camber. Camber means giving that flat surface that produce a sheet of uniform thickness during rolling. So now this is a very advanced topic. We are just mentioning it. In real industry, this happens very, very few times because they are always designed in such a nice way that this never happens. But if this happens, then you need very advanced practice people who have years and years of practice, and then they can play with the design of the rolls. Slab spread, right? It is a simple thing. Slab spread. You see, this is your initial slab. This has bigger thickness, and once it goes through the rolls, the length increases, the width increases, right? So this is the spread, right? The height is decreasing, but the width is increasing. So there is a spread that will always happen in rolling. That if it is a simple rolling, not shape rolling, then it will decrease the thickness, but will increase the cross-sectional area. So this is called slab spread, right? Increase in the width of a strip during flat rolling. This increase in the width is called spreading, right? So spreading can be similarly observed when dough is rolled on a flat surface with a rolling pin. In your house, anywhere, if they are making bread, they take a small round dough, right, wheat, and they take a rolling pin and roll it, and this exactly happens, that the thickness goes down, the area increases. So rolling exactly does that. Now these topics, are again left for you as a self-study. I am doing that repeatedly, right? I did that for forging. I am doing for some portions in rolling now, and when we will go to extrusion and so on. I have told you that there are two purposes. One is that you become independent, that without the teacher's assistance can you still understand a few things, right? And second, that your reading and understanding habit increases. Both are very, very critically important in your practical life. Once you become an engineer, for 30, 35, 40 years you remain an engineer, and you have to read lots of manuals and big books and this and that and standards and so on, right? So these are the topics. Defects in rolled products, vibration and chatter in rolling, flat rolling practice, and miscellaneous rolling operations, right? Again, what I have done is, though I should have left it totally to you, that go into the book and do it yourself, but I have already made slides of it. So at least the pointers, the overall idea is in the slides, and then you quickly go to the book and skim, very quickly scan. I have promised you, and that I will keep, that from the area where we actually do the full detailed lectures, we can have full problems and so on. But from the self-study side, we will not have numerical problem solutions, but small theory questions and quick multiple choice and so on will be there. So let us see what are these topics. Defects in rolling, right? Some other defects in rolling are also shown. Vibration and chatter. When vibration is there, there is a chattering, there is some noise that can happen in rolling. That is also a bad thing. Flat rolling practice. How do you do that? Roller leveling. How do you level? Roll arrangements, different types. 2 rolls, 3 rolls, 4 rolls. How do you do? And at the bottom, a planetary system, sun and planet type of rolling system. Miscellaneous rolling operations, different types of rolling operations. One is shape rolling, right? Where we just don't reduce the thickness, we also give it a shape. So here in shape rolling, blooming rolls and edging rolls and different types of things. And you can see in the last diagram is stage 6, there is an H-beam or an I-beam, which is ring rolling, making a ring by rolling up, continuing with ring rolling, trying to explain it with another type of slide, and then one more, so that you see the same operation from, say, 2 books or 2 different sources. Thread rolling, you are rolling but you are producing. So this is one slide of thread rolling and another slide of thread rolling, and a third slide of thread rolling. Different kinds of thread rollings are there. Thread microstructure. So this is just that, you see, when you are doing threads, then what happens to the microstructure, to the grain size and so on of the material, of the metal. Mannesmann process. This is great. If you see the last diagram on the right, you can produce tubes, hollow shapes during rolling. All previous ones, first rolling is flat rolling, means you are not changing the shape. In shape rolling, you are producing I beam, W beam, H beam and so on. But this Mannesmann process is remarkable that by rolling, you are creating hollow shapes like tubes and hollow cylinders and so on. You see now that we are on the next major manufacturing process of bulk deformation type called extrusion, right? Called extrusion. So we will talk of extrusion later on, but this means that the topic of rolling, as far as we are concerned, is finished. The major part, the understanding, what is the operation, what are the different types of things involved, using the slab method, the mathematics, numerical problem solving, all of that is done. And small topics like what are the different types of machinery and this and that is left for you. So in the bulk deformation chapter until now, we have done a general introduction of bulk deformation operations, hot working, cold working and so on. We have done a full detailed coverage of forging, and now we have done a full detailed coverage of rolling. Extrusion is another bulk deformation process. Bulk deformation means we do not melt, we do not cut or remove any material, but we directly deform into the shape. So before we go into extrusion, let us take a small break to refresh your mind. So this is the break time. Very serious something. Now this is a very big major book in physics, States of Matter, by David L. Goodstein or Goodstein. It depends on whether it is German or English pronunciation. It's a major book by one of the major authors. And I'm showing you here the introduction of chapter 1. Chapter 1 is thermodynamics and statistical mechanics. It is a major field. And I have highlighted, so sometimes jokes are not jokes, they are real things. This is a very big author who really understands physics, and thermodynamics and statistical mechanics are high level things. But let us go and see what I have highlighted. Ludwig Boltzmann, who spent much of his life studying statistical mechanics, died in 1906 by his own hand. By his own hand, he committed suicide. Paul Ehrenfest, carrying on the work, died similarly in 1933. Right? He took his own life. Now it is our turn to study statistical mechanics. Joke is over. So generally we take much longer. The actual class is 1 hour 50 minutes, but we at least do a little more than an hour and so on. But today, because we have finished rolling in detail, and when we start extrusion, I want to do it in a continuous way. So you have a shorter lecture, right? So from you to me, lots of thanks, okay, for a shorter lecture. And we stop here today, and we will continue later on, inshallah. Thanks a lot. Ma'as salama.